Yes, good afternoon, students. This is for it is peripheral and some extra lectures. Is that okay? Fine. Now, good afternoon. Here some questions like separate notes, not separate notes in your regular classroom, please, but take notes. Is that okay? Fine. Yeah. Now our topic will be, that is damped oscillations. Is that okay? First, today we will start with damped oscillations for sometimes small topic, followed by that is optics. Is that okay? I will give you the that is plan also, what will be subsequent lecture plan also, so that you can mentally get prepared. But right now, first we will start with damped oscillations. Is that okay? Okay, first that is this you would have studied. Is that okay? Undamped SHM you would have studied. Is that okay? Meaning how the equation used to be. Please be attentive, and any questions, keep on typing. What is the chapter name? Damped oscillations. It is damped oscillation. Okay. Now in that rapid recap. You would have done in your oscillation, that is undamped SHM oscillations. Is that okay? What was the equation? M into acceleration. Is that okay? That is minus kx. This is what you would have done. Is that okay? A is minus k by m into x, right? This only called as omega squared, minus omega squared x, like this. Here no damping. Is that okay? It is undamped situation. Is that fine? And then that is omega is under the radical k by m, like that. Is that fine? And solution of this equation, solution of this is what? D 2x by dt2. What is the solution for this equation? Do you remember? Which is y is a sine omega t plus phi. Is that right? Yes or no? Say yes. Keep typing. Yes. Very good. Right. And now in this we are now entering into damped. Is that okay? Meaning some resistive force will be there. That okay? Here no resistive force, smooth, so keeps on oscillating continuously. Yes, forever, unless somebody deliberately stops that, keeps on oscillating forever. Whereas in our case, damped, that okay? If some friction, let's that is generally we consider that is air resistance. Is that okay? Some resistances. Is that okay? Fine. Omega t at omega y is a sine omega t plus phi. Omega is the frequency, Nipun. Omega into t, that is right. Omega into t plus phi. Nipun, right? Understood? No problem. Now damped oscillations. In that damped harmonic, means any harmonic means sine and cos. Based on that, the answer will be. Is that okay? In simple means first degree, like that. Is that okay? Fine. Damped harmonic motion. Fine. Here, that means what? There will be damping force. There will be resistive force. which we call here damping force. What damping means what? Some resistance suffered. Is that okay? It can be even friction, can be some, there can be situation where this, see, it keeps oscillating. Fine. Now you are putting this, it keeps on oscillating. Now you are immersing this in a liquid, right? So it keeps on oscillating, but now amplitude will keep decreasing. Amplitude will keep decreasing. Is that okay? Viscous liquid. Yes, yes, absolutely right. Viscous liquid. Yes. So the force suffered we call by the liquid here we call as that is damping force. Even air resistance damping. Is that okay? Atharva. Okay. Atharva, please maintain patience. We will move on. I will tell you. Don't worry. Remind me after some time. Is that okay? That phi is phase constant. They say phase constant. Initial phase constant. Please maintain patience. Any non-conservative force will necessarily cause damping. Wait. In general, if you see this statement, we cannot take it darsha. Take any non-conservative. Say, acha, you mean in what do you call, in only oscillation you mean, or in any case? If this is the oscillations. Then it is okay, like friction, that is fine. But in a closed loop, okay, I'll think and let you know. Please maintain patience. You cannot generalize and suddenly tell. Please maintain patience. Yes. Conservative. We'll come back to that. Don't worry about Dash and our I think now because I'm thinking of getting counter example, but okay. So undamped means horizontal and damped. Not that way. Who is this? Atharva? Not that way. See here. Listen. You take a spring block system, keep it vertical only. Okay. Atharva. Spring block system, keep it vertical. Fine. Only weight and the spring force acts. Is that okay? Then it will keep on oscillating forever. Is that fine? Agreed? Right? Wait. Now if that is if the same system is immersed in a liquid, viscous liquid, or even leave it air resistance, if it is considered, after a long time it will slow down and get slowly, it will come to rest, correct? Its amplitude keeps reducing. Agreed? That is damping resistance. Is that okay? Understood? Now means resistance. Yes. Stops. Yes. Keeps damping, decaying. Yes. Right. Damping, decaying. Right. Will cause damping. Any type of resistance. The moment you say resistance will cause, yes, damping. Right. Now, okay. Listen. Now, All right. So it keeps on oscillating fine. Keeps oscillating fine. Now we will consider as that is damping force, resistive force given by someone. It can be air resistance or whatever is that. Many type of rules or laws are there for resistance force. In that special cases, it depends. That is, in several cases, friction force depends on that. A damping force depends on B. Is that okay? Damping force depends on speed. Depends on B. Is that fine? So we are in many cases that we are considering. Not that always damping force will be proportional to B. No, not that. That is not the generalized one. But in many cases, it follows this rule. So for this we will work. Is that okay? Understood the situation? Damping force in several cases. Yes. So we will break it. We will call it a BV. Is that okay? Some where B is proportionality constant. Right. So now how our equation will be, you only tell like this. It will be M into acceleration dV by dt will be minus kx here. If at all, if block is like, right, block is over here, this is origin positive, this is x, right? So minus x into k, damping force like this, right? And resistive force, please wait, I will draw once again here. We will consider here. Symbol B, proportionality constant. Is that okay? Spring attached. Wait. Yes, please wait. Now X, it is moving this way. So Kx, what are all the forces? Kx, let speed be in this direction. So damping force will be like this, right? Which is BV. Now how they equate two forces? This is damping force. This is damping force. This is spring force. Now how the equation will be tell? M into dV by dt is minus kx plus BV plus BV. Are you agreeing? Plus BV. Is that okay? So if you want, you can rewrite like this: minus kx minus BV, like this. So M into d2x by dt2 is minus that is kx minus BV. Is that okay? Direction of damping. Listen, Siddharth, please listen. Yes. Now see, we are considering situation where the block is over here and moving towards left, right? Siddharth. Now, friction force will be opposite to this, opposite to the direction in which it moves. Is that right? So friction force like this. Our positive is towards right. As per our convention, our positive is towards right. Now write the equation. Write the equation. M into A is net force. Net force is minus kx plus BV. BV is positive. BV is in positive direction. Spring force is negative direction. So minus kx plus BV. Is that okay? Understood? Now see. X can be, V can be written as rewritten as what? M d2x by d t2 equals minus kx plus b into dx by dt. Is that okay? This is the equation, right? That damping force is a variable force, Aditya. It keeps varying. Is that right, Aditya? It keeps varying. Our hero, who is that? Aditi, here, whatever value you get, if it is positive, it will be in positive direction. If it is negative, then acceleration will be in negative direction. It keeps changing. Is that okay? It is sinusoidal only. Generally, in our SHM also, undamped SHM also, it keeps on changing, right? Damping force will opposite to the motion of an object. How can it be directly performed? Magnitude, understood. Who is this? Magnitude. Himanshu, you are right. You are absolutely right. It is the magnitude. Is that okay? If you want, you put like this, right? Got it, Himanshu? Then it is also force, Anurag, force. Here it is fluid friction. If at all, if it is air, fluid friction. Who is this? Our Sai. Understood? Fluid friction only. Right. Sign will tell us about that. Right, Aram, you are right. What is V? In BV, it is the speed. It is the speed. It's the velocity of that object. Who is this? Our Shreyans. Clear? It is velocity, depends on velocity. Greater the velocity, greater the resistive force. If you drive in a car, lesser the speed, lesser the air resistance. Greater the speed, greater the air resistance. Shreyans. Agreed? Right. Amplitude decrease. Right. Okay. Anuja, yes, please wait. I will do that. Slightly write it bigger from next page. Keep reminding me. Ayush, amplitude decreases with time. That's right. Damping force is opposite to the Pratik. You are right. Opposite to that. Okay. Soham. Right. Soham. See, dV by dt. How do we write dV by dt? dV by dt, which is d by dt of what is V? dx by dt. That is the second derivative. We write this only like this, d2x by dt2. Who is this? Soham. Understood? Soham. What is major difference between undamped and damped oscillations? Right. Atharva. Nothing. Undamped means it will not come to rest. It will not go. It will keep on continuing is the oscillation. Damped. It keeps reducing because of the viscous force or because of the resistive force. It slows down and finally comes to rest. Atharva. Understood? Atharva. Yes, right. It will come to rest after some time. It means after a long time. That we will see. Atharva, understood. It is same like friction. Yes. Right. Undamped is ideal in nature. Right. Okay. It's all right. Yes. As time flows, you will get it. We will move ahead. Last, please wait. Sharva, please wait. We will do that. Last equation is the general equation for damped oscillation. No, I should not. We should not say like that because we don't know that viscous force. Or else, don't write that BV without without that you write here that is BV friction viscous like that you write. That's all. Because we don't know the law. There can be viscous for the damping force which will be of B squared, BV cubed. We don't know what is the rule. This is for a special case. That's why I wrote several cases, which is several cases of interest. Right? Right. Here spring compressed. It's now it's elongated mean. Here only natural length, mean position, natural length. Okay, please wait. Everyone, please maintain patience. Yes, it will come to rest due to friction. Wait. Not get how you derive the equation of damped oscillation. We are not derived. V is velocity. Yes, that's we will continue. I did not get the. Please wait. Aditi. We are please, your doubts please post it to everyone. That will be better. Others can also see. Or else they are not getting. Simply I am giving. Yes, understood. Please post your doubt to everyone. The others also can understand. Right. Right. Listen. And now Aditi. Here there can be more than one damping force possible. Yes. You write the equation if possible, if it can be, if that equation can be solvable, good. If not, use numerical techniques to solve. Write the equation F1 plus F2 and F3, F4. F2 and F3 can be damping. Yes. F4 can be something which can deliberately be a forced one, which we will see later. Subsequently, we are going to see like that. Equals M into A. That's all. Wait. We will please move ahead. Clarity will follow. Please wait. Now listen. We will once again. That is dv by dt can be rewritten as d2x by dt2. Now listen. We will once again. I will write the equation. Can be rearranged. Siddharth, we generally deal with damped force in our everyday life. Okay, where? Tell me. Air resistance, it comes under damped only. Haram, yes. Now tell me one example. Our hero Siddharth every day, where this damped oscillation comes. Can anyone tell? Any spring mass system, right? Absolutely right. Your pendulum, fine. Pendulum in real life situation, swing in garden. After long time, it comes. Right. Yes. Fan stops moving after that. That is friction. In oscillation, you tell. Bouncing ball. Suspension. Who is this? That's absolutely right. Ankar. Swinging pendulum. All right. Swinging branch. Yes. Suspension. In which that is even scooter, two-wheeler suspension. Shock absorber. This is mainly for damping. Shock absorber, it dampens. Is that okay? It wants to dampen. Its job is to dampen. Is that okay? Shock absorber. Yes. Now listen. Guitar say, okay, okay, fine, 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 fine. Yes. Now, important thing is we don't know how to solve this. If B would have been 0, we can solve. We know how to solve it. That is what we have done in our oscillation harmonic. But such is not the case here. This is what? Second order. Is that okay? Second order differential equation, not in our syllabus. Only special type we know, our oscillation. Leaving that, no, whenever this term comes, difficult. Is that okay? Generally, yes, somebody wrote it as d squared like that, they write. Correct, correct, correct. This equation we don't know to solve. You will be studying that in your engineering. I will give the result. Is it okay? Say yes. You have to remember the result and proceed. Yes. Right. So that means X is, solution is A naught into e raised to you have to remember BT by, that is 2m into sine of omega dash omega prime t plus 5 delta or delta 5, anything is fine. Who was asking about 5? How somebody was asking about 5. I forgot the name. Differential equation, second order differential equation for us. Atharva, please, Atharva, maintain patience. As time flows, I will keep telling. Okay, how to get that to 5? Atharva. Is that okay? Right. What is omega dash? Comes the question. It can be sine, cos, because somebody who is writing it as sine can put 90 and make it cos. So not a problem. Plus delta. Okay. If you want, you put as 5, no problem. Okay, 5. If you are comfortable with 5, please put 5. No problem. Phase constant. Right. Power of E is B. Oh. Okay, I will read it. X equals A naught into initial amplitude into e raised to minus BT, that B constant, that okay, BT by 2m into sine of omega dash t plus 5. This is the solution of this equation. I will tell you, no problem. Each term, yes. Sharvin, please wait. Yeah. A naught, initial amplitude, right? Then B, the proportionality constant which appears in the viscous force. Omega prime, what is that omega prime? That is the damped frequency. Without damping, if it works with some, if it oscillates with some frequency, if damping comes, frequency won't be same. It will be something else, right? That is damped frequency, damped angular frequency. Damped angular frequency. It is not normal frequency, it is angular frequency. Won't the frequency change? It is not changing. It's not changing. That is the result. That's the result. You feel that way, fine. Okay, it's coming that way. Okay, our Tanishk, Sumedha. Relation between, yes, that I will tell. Where omega prime is inside the radical, omega naught squared minus B by, please commit to memory because you don't know how to solve this. So you are accepting, right? Where our omega naught is our standard, natural, that is the undamped frequency. Understood? Any difficulties? Now is the connection clear? This is going to be the new Siddharth. Yes, something you're trying to tell, please. Yeah. That means omega naught squared. This is the connection between damped frequency and undamped frequency. Right. If for small b, for small resistive force, if b is small, tell me what will happen? Then omega prime becomes almost omega naught. Understood? Till this on track. Till this on track. Right. Very good. What is k upon m? K by m. Our regular k by m, omega. E, our standard exponential E only. Now, how the graph will be? How the graph will be? Comes the question. Listen. Anuja, why crying? What happened, Anuja? Getting or not? What is M? Mass. Mass of the block. It is C. Same thing. This K and M. Okay. If that damping would have been there, what will be the omega, new omega? That omega only will be plugged in over here. So listen. We are multiplying. You would have studied in graph. Is that fine? So when T0, it is let us take such a phase constant where somewhere here, right? If what happens to e raised to this means it is exponential, right? So it will keep on coming like this. Sine. Please, any difficulties, tell me. Any difficulties, tell me. Right. Right. And sine. So it will be like this. It is 1. Right. So graph will be like this. It will keep going. Agreeing? Or you people agreeing? Or if not, please tell me. Yes. Omega naught is the when no damping is there. If damping wouldn't be there, if no resistive force wouldn't be there, then with what frequency it will keep oscillating? Your Yaskacham. Omega is under the radical K by M. That only. Right, Shahid. Blue graph. No. It is the border. It is a graph of this. And sine is it. Okay, I will tell you. Please wait. Explain again how did we get the graph. Please wait 2 minutes. Now listen. Right. Let us take y is e raised to say minus x. How the graph will be exponential. Na? Wait, I will come to Atharva, I will come to that. Don't worry. Again, we will go there. Wait. Aditi. Maintain patience, Aditi. Okay, 1 second, last slide. Yes. Right. Listen. Now, e raised to minus x, how it will be? 0 means 1. So graph will be like this. Agreeing? Next, we will take another graph. Y is sin x. How the graph will be? It will go like this. Even we will take y is sin x only we will take, right? It is 1 like this, like this, like this, like this, right? It will keep on going, right? Understood? Now, let us, that means here border will be 1, 1, always. It is y is sin x. Now what we will do here, minus 1, like this. Now what we will do, we will take product of both, right? That is, y is e raised to minus x into sin x, like this. Now, see, here one will take some other color. Because of sin 0, though this is 1, 1 into 0 is 0. Agreeing? Now see, though here sin is 1, this is less than 1, 0.5 say. So 1 into 0.5 here only. So graph will be like this. Now, though this is non-zero, into sin is becoming 0, 0. Now see, this is minus 1. Minus 1 into this value will be minus of that, like this. So sin is making the exponential graph 0. Product, you are multiplying. So like this, it keeps on. So it is the bound. Right. Oh, sorry. I will erase that. So if you see, like it will be confined between these two graphs, like that. Understood? For Siddhant, please don't mix that here. Graph, that means here e raised to minus x v2. If it would have been, say, for example, another simple example, somebody is telling e raised to x, graph will go like this and take the product of like this, means then how the final graph will be after taking the product. Wait, please wait. I will show you. No problem. No. Like this and like this. So because of 0, 0, but whenever it comes to 1, whatever the value is, when it comes to 1, whatever the value of the graph is, that exponential, it will be like that. Then 0, then again here, again it will be going like this. So in this case, it will be going like this. Understood? Two graphs, Vedant, please wait. Blue graph. Wait. Isha understood. How many understood? Raise your hands, or put something. Yes. Right. Okay. Right. Now put down here. No problem. Enough. Don't worry. This is more dry. As we go further, yes, topics will be interesting. But now this topic where we have to remember the result and proceed. No go. They are kept in the syllabus. We cannot derive that because not in our curriculum. That is the thing. Now listen. Who is that? Varad saying that. Can you explain the blue graphs? No, wait. Listen. Once again, I will explain and then we will move ahead. No. Now see, this is sine graph. Varad, sine graph. This is exponential graph. Okay. Now, Varad, are you there? Then, if you take product, when this is 1 into whatever exponential, it will go to that value. If this would have been 1.5, exponential would have taken 1.5, 1.5 into 1. So 1.5. When it is here, minus 1, if this would have been 2 into minus 1, minus 2. So it keeps on going. When it is 0, whatever be exponential, it will be 0. It will come here. So when you take product of this and this, it will be going like this. It will keep on touching the exponential graph. The exponential graph will be like the boundary. That okay? Sine keeps going like this. Understood, Bharat? Like that. Okay. Now coming back. So this is what will happen. This decides the boundary like this. Yes. Whereas this oscillates. But oscillation frequency won't be our undamped. It is damped frequency. How much is damped frequency? Given by this rule. Omega dash is under the radical omega naught square minus b by 2m whole squared. Any difficulties? That b is the damping constant. Is that okay? Because it appears in the damping force. Is that okay? Now here, you are not. Don't try to understand how this equation is coming. That proof we are not doing. Is that okay? You are accepting. After this equation, differential equation, you have to accept. Anuja. Done. Right. Okay. Now listen. Listen. Behavior of damped oscillator. Right. E raised to minus x into sin. Yes, absolutely right. Yes. Yes, Raman. Now, xt graph, right? Yt, right. Xt, right, okay. Current topic is damped oscillations, Ishita, only for some time. And then we will move to geometric optics, right? Right. X and Y, they okay. Here you label this as, this is time and this is that is X position. Right? Paras. Okay. Now, initial amplitude on the graph. No, initial amplitude given as 0. It can be left from here also, no problem. If it is mean position, you give a hit so that it moves with some speed, or you pull it up and then release it from rest. Anything is okay. Or it can start from anywhere. For the matter, that is not a big deal. That is the initial situation, how you give. At some position, you may go on to throw also, hit also. Not a problem. Okay. In the graph, it is 0. The graph shown. Okay, Shuten. Okay. Now listen. Clarity will follow. Please maintain patience. And now, Soham. Right. Boundary is by exponential. Right. You do graph, na same thing applied here. It's useful over here. Yeah. Now listen. If damping would have been more. See, listen. Undamped. Undamped. Keeps on oscillating, right? Damped. Yes. Suyog, memorizing. Remember that. No go. Yes, you are right. Then, if damping increases, tell me, if you increase the damping, it will keep going like right. Agreed. But still there is oscillation. Is that okay? Increase till the damping. Increase till the damping. Oscillation still reduces, right? Still increase the damping. It may not oscillate also, right? The damping for which oscillation just stops, critical damping. Damping for which oscillation just stops. This is called critical damping. Understood? Critical damping. Object comes to rest, then at that time the graph will reach. In damping, it is exponential. Given some, that is what the tolerance, some value within which if it touches, then we can claim that it has come to, then fine, we can claim that it has come to mean, or else it will never. In principle, theoretically, it won't come only. Exponential, it is asymptotic. It is touching at infinity. Right? When oscillation tend to stop, then it is known as no, not tend to okay. You are meaning carefully. We have to take weight, right? See, less damping, it will keep on, it oscillates. No damping, keep on oscillating. Less damping, TK, oscillation, the amplitude slowly decreases, but it will oscillate. Like that, give damping, still increase the damping, it will oscillate and less number of oscillation. The damping, the situation when it doesn't oscillate only, just comes to rest. Is that okay? That is critical. Just oscillation stops. There can be situation where huge damping. Without oscillation, it will come slowly. But that is not critical damping. Critical damping is the situation where just oscillation doesn't happen. Is that okay? For such a such a damping referred as critical damping. Damping proportional to speed. Don't say it as amplitude. Whether it is at 10th centimeter or is it at 20th centimeter, its speed decides the damping force. Is that okay? At 10th centimeter, 20th centimeter, if it goes with same 1 centimeter per second, damping force will be same only. So damping depends on speed. How is damping? Okay, fine. Damping coefficient for our theoretical treatment. Who is our Atharva? Still critical damping. Does it mean damping force is large enough to stop? Yes, to stop oscillation. Not very large enough also. Large enough to just stop that oscillation. Just Kaivalya, to just make the oscillation stop. Object can have motion, no problem. He's asking whether during damping object will have motion or not. Yes, it will have motion, right? Yes. See, in our two-wheeler suspension, if you take also any four-wheeler car, spring is for suspension. It doesn't allow the jerk to come in. It takes the jerk and for us, no problem. But it should not happen that we keep on oscillating. So it should be damped also. Jet should not come, spring, and damping should not is there to stop oscillation, or else we will keep on oscillating and keep going. No, that is very bad situation. So it won't be good. Only with spring, if you keep driving without shock absorber, it will be funny. Is the logic clear? Our Kanishk is saying critical damping has less. Don't connect that way, Shivam. Critical damping, it stops the damping. Speed can be anything. Give greater amplitude and leave it, speed can be differing. It depends on the amplitude. Will always occur at t equal to 0 and no critical. Wait, Saket, wait. Everyone wait. Damping force is a resistance. Yes. Which comes in oscillations. That's all. Yes, Sanjay, keep it. No. This is not fast. Don't worry. These are peripheral topics, so nothing to worry. We are not going. This is not fast. Please don't worry, our Sanjay. Keep on following. You don't think about anything else. Whatever we teach, follow. Nothing to worry. We will take care of the headache. You simply follow. Assume mass of object. So in critical damping, it will oscillate and stop. No, it won't oscillate and stop. It will come to stop only. Wait. Please wait. Everyone wait. With undamped, damped, still damped, critical damping, too much damping, too much damping. Actually, I should have done not this way. That actually this also okay. It means we are giving hit when it is in the mean position, or pull it and release it. That can also be done. Pull it and release it. Anuja, why Anuja crying? Anuja is like this. Undamped, damped, again damped only, critical, just it will keep oscillating, it is ending the oscillation, too much damping, like this also, right? Oscillation ends, that's all. Aditi, very good. During critical damping, will the object still travel? No, it won't try. It will travel not with V. V keeps changing. If you want V, that you can get it again by differentiating this excess time, xt graph. Wait. Can we all, most of the non-oscillatory motions are most of the non-oscillatory. Don't say non-oscillatory. Why? So you are running and you are stopping. Where is then damping here? It is friction. That concept itself is gone. During oscillation, we bring damping. You take spring. With if damping wouldn't be there, it will keep on oscillating. You want damping. So shock absorber also is being brought in. That's all. So simple. Now you have to think like this. Understand why spring is there. Why shock absorber is there? Bas, so simple. Explain it. Third graph. 1, 2. Can you explain? Wait. In red graph will not cross the time axis. In overdamped, it won't cross the time axis. I made a mistake here. I don't know why it has gone. Right. It won't cross only. Right. You are right, our hero. Siddhanta. Right. You are right. Absolutely right. One find the asymptotic only, but right. You are right. Now, wait. Okay. Vary with how will the time period of oscillation vary with it is, if it is damping, it will slowly oscillate. It will slowly oscillate. So frequency is less. Right? Time period will be more like that. Red graph, everything. Red is for everything. It is undamped. Okay. Undamped, damped. More damping. Still critically too much damping. Over damping. Right. Second last graph is just touching. No, anyway, it will come and touch. All will touch. No doubt about that. On fine day. Name the blue graph. Same thing, Ray. Same thing. Blue also same thing. Too much critical damping. Same thing. Ambush. Okay, listen. Now we will move ahead. Further, we will come back. Don't worry. Long way to go. Kalpat, please wait. Please wait. Just approaching x-axis. Third, no. Third is not critical. First, second, third, fourth is critical. Fifth, overdamped. But the wavelength is different. Here, there is nothing like wavelength. It is not a wave. To talk about wavelength, first keep this also. It is not wave. Disturbance, oscillation. That's all. We can say critical when body never completes one single. Okay. Just it. If it would not have been critical, completion will be there. Oscillation will be there. So it is not critical. It's not oscillating. That's all. Ending that oscillation. Touches at infinity. Yes. Okay. Please wait. Clarity will follow. Now we will further move ahead. Don't worry. Okay. Don't worry. As time goes slowly, we gain mastery. Don't worry. You understand why subject is like that. Slightly dry. Don't worry. Now listen. No, I don't know how many that swing or even that. All right. You keep oscillating it, right? For baby, yes. Right. If you leave it as such, it will go with some oscillation. Saurabh, mean position. Saurabh, please listen. We will come back. Don't worry, Saurabh. Listen. Say yes, Saurabh. Are you there? Come on. Be attentive. No problem. Here, don't think that I have to become king of damping, then King Kong of damping, then we will move to next. No, don't do that. I am getting nice. Next. It will slowly gain that mastery. Don't worry. Now here, if you leave it as such, its own frequency. But if you want to make it go in your own frequency, you have to push, correct? You keep pushing it regularly, right? So forced oscillation then. You are making a system to oscillate in your own required frequency, forced oscillation. Right? Understood? Forced oscillation. Not pendulum rhythm. That'll be, even you can take swing, you take swing. Some kid. Right. Right. So natural frequency is one thing. Force this, if you want to see, if it is going with 10 oscillation, see, per oscillation 2 seconds. If you want to make in 1 second only one oscillation, yes, then you have to force accordingly. Forceful, right? Forced oscillation. That okay. And that force must be periodic. Right? Many type of periodic forces possible. In that, our interest, academic interest. For our academic interest, we take sinusoidal force. Can you define the force? Oscillation, Neeraj. Oscillation obtained by a periodic force. You also keep. There it was only oscillating. If you deliberately go and push it with, you want it with one oscillate, it is oscillating for every 2 seconds once. You want it to oscillate every second once. So you have to push, correct? Deliver accordingly. You have to give such an input you should give, calculated. Is that right? Now periodic force can be plenty. Periodic functions. Any periodic function, you can convert it as a force and give. But special force, is that okay? For our academic interest is sinusoidal. That we will give. Is that okay? So F is F0 sine omega t. Any difficulties? Right? So here our equation will take the shape, differential equation. M dv by dt is, right, our mine, that is kx minus bv. And keep in mind, why it is only bv? Can't it be bv squared, b into root b? It is the infinitely many functions possible. Please write whatever is there behaving, you put it, but this is for our academic interest. Please don't think that this is the only way force will be, we will get damping force. No. Right. F0, it is a varying force. Sinusoidal force is being given. Sinusoidal force is given. Atharva. Sinusoidal force is given, which F is F0 sine omega t. Right? Is that okay? What is after kx? Minus bv. That force, damping force also is there. Damping force with our sinusoidal force. Right? BB, earlier one, viscous force. This is viscous force, damping force. This is our input. That is oscillatory force. Spell it out. Which one? Our Pratik. Which force to be spelled? Yes, tell me. Last one. Be clever. Which one? F. Paras. In the wait. Equation written for the wait. What is the force? Can you spell which? Oh, sine omega t re. Sinusoidal. Wait. Who was asking for? Pratik, understood, yes. No, second derivative not in the syllabus. It's in engineering. Yes, not. Okay. Given you take that way, it is in the direction of the applied force. Applied that original one, spring force, and this both are in the same direction. Like that you take. If it is opposite, you change the phase constant or put minus, or you write plus f naught sine omega t plus alpha, like that you solve. What to do? And this is one sign. If somebody says another two forces are there, which another exponential or something else, 2, 3, your logarithmic, whatever is there, please do that. Solvable or not is a question mark. Or you can solve anything numerically. Is that okay? Numerical techniques can be used. Then anything can be solved. You want to get the answer classically, the way you do the differential equation, like that means only problem. Many unsolvable equations are there. That okay. Kritika, right. Okay, now listen. Again here also, rotating fan. It is not oscillation ray. Otherwise, fan is not oscillating. Fan is not oscillating. Are you getting? Right. In the hand fan. But the hand fan also fan only. Where is oscillation? Hand fan. Can a spring with Nidhi? No. Okay, listen. What is Nidhi? F naught. F naught is, see, if you give oscillatory force itself keeps increasing, decreasing like that. Is it okay? If when in this case, when it is like this, when it is like this, one force is what? Spring force. Agreeing? Nidhi, spring force will be there. That time, there is one more force like this. F naught sine omega t. This is the rule. Whatever is that, please put the time accordingly. Whatever is time, you put. So what F you are getting, please, will be applied. It is oscillatory force. The F graph itself of F naught and T will be like this. Initially 0, then goes, increases, then more force, then less force, like that. Is that okay? So it means for a block, you may apply some force, then after some time a bigger force. Again, it may even in the same, before it comes to rest only, it would have even oscillated. We don't know. Is that okay? Initially, transient situation. So that means this is it is like this, then like this, then like this, then again coming here like this, then again coming here, then 0, 0, then force keeps changing the direction. The force itself keeps oscillating. The input force is oscillatory. Understood? Our Nidhi, got it? F naught is amplitude of that force. Force itself is variable. Sinusoidal variation. It like sine, it increases, becomes 0, opposite direction, then it becomes 0, then increase, like that. Understood? Like that. Now comes the result. I am giving the result. Okay. solution is X is A sin omega t plus phi, where A is F0 by M whole upon under the radical omega squared minus omega naught squared whole squared plus B omega by M whole squared, where omega naught is, we know that under the radical K by M, right? Now forced and free oscillation, no, forced I am getting, but what is free oscillation? What do you mean by free? With undamped you mean, or what? Soham. In vacuum, then in vacuum, damping force won't be there. He wants to get unmuted. Where? Wait, Ray. Soham. Soham here only is there. I asked to unmute. Yes, Soham.
So I was saying that in forced oscillation and in free oscillation means in the oscillation which is not facing any damping force, or in vacuum, the equation will remain same now.
Whatever we have done, undamped oscillation, that is undamped. So that you are meaning.
Free oscillation means undamped oscillation. Yeah.
Right. Agreed. Forced and you mean forced and undamped oscillations will have same equation. You mean solution or the differential equation? He suddenly went into that mode. You mean a differential equation? No. Na. In normal, in undamped, only this kx will be there, na? Only that undamped. Yeah, yes, you are right. You have to memorize the result. Commit to memory. This alone will be there. Here, this will come. In vacuum means this won't be there. This will be there. Right. Understood. He understood. Yes. Now, omega in that means system will. We must get previous case. Okay. That means, listen, have to double integrate. That is okay. But to get solution, it is integrating, it becomes headache. Why? Because both that is first order and second order, both are there. That is the problem. You cannot separate the variable only. So there are techniques for this. Don't worry. Now listen. Here, omega, that means finally the system goes with whatever be its natural frequency. Leave that. It finally obeys forced frequency, omega. That's all. That is why omega is here. Result is having omega. Are you getting understood? Finally, it will be final oscillation frequency will be omega 1. Because forced fellow only dominates. Is that okay? Now listen. If we will conclude this and then we will move ahead. Because here much to you have to remember only. Is that okay? Omega naught is greater than That won't happen. Omega not, please wait then. Please wait. Amplitude becomes maximum when right. I'll leave it this. No, please leave it. I will write some other point. Okay. This is resonance. How a value comes this. Wait. Please wait. Now, this. Oh, okay. Your question is how this has been obtained. That is by solving. Shivam, it is by solving this differential equation. It is solving this differential equation which we don't know. We are accepting. What if periodic force is absent? Who is it? That's and what you are saying. Is it damped or undamped? Is damping there or not? Is damping there or not? That's in this case damping there. Simply remove it. The earlier answer you should get. It is earlier answer. That earlier means here. This situation. This one. Same equation only, na? Only thing we are putting here plus that is minus f naught sin omega t. That's all. Omega equals 0 in the new. Okay. Amplitude B. Wait, first of all, we will remove first of all, f naught only will. It is new amplitude. It is not, what is that? Damping. It is not damping. It won't damp. Is that right? Understood? Fix the amplitude. And it is sinusoidal properly. No decay. Is that okay? So, explain. I am not explaining the solution. I will explain whatever is written, that each term I will explain, because we are not solving it. Wait. Variable omega oscillate. Is the variable omega in oscillatory force the same? No. Yeah. Wait. Final answer. This one is this omega. Who is that? Good. That question is a good. This and this same. Who was asking? Pratik. Understood? So that is why I'm telling. Finally, oscillation will be that is controlled by forced oscillation. If forced oscillation, natural frequency may be 2 oscillations per second, but forced oscillation says I want 5, and accordingly it is forcing. So final answer will be 5 times only, no doubt. It is, but not damping is there. That all will decide the amplitude. That's all. But amplitude finally will be some fixed, which will oscillate with that forced, that force, oscillatory force, that force frequency. What is the force of the forced that oscillation? That omega. it will oscillate with this that I am marking. This one. Are you getting or not? How we will get to know when oscillatory force will exist? And they will give. Sejal, they will give. Na? Without that, how you will? If in a question paper also, if they give you, find. Unless they give further, you can't find what you will find. Like that only. Something they will give. Don't worry. So force is countering the damping force. Right? It is not countering or not countering. Anyway, it will be like that only. Damping will be against that force because finally it is forced oscillation, which that is the frequency of the applied force. That only applied force, external force, that oscillatory force, that only dominates. Right? Natural frequency doesn't have anything here now. Understood? Siddharth, please wait. Siddharth wants to unmute. Amplitude will be constant then. Final amplitude will be constant always. Right? Understood? Wait. Now who is this? And also I won't. It won't be. It is damping is there, but it won't decay. The damping for viscous force is there. It won't get damped. That's the better way. Word. It won't get damped. Viscous force is there. A resistive force is there. Right. It will keep oscillating only. Wait. Who is our? Wait. Causing the our who? Siddharth wants to get Siddharth. Siddharth. Yes, Siddharth, you are got unmuted, please.
So can you hear me?
Yes, I can.
Sir, I wanted to ask that also in undamped force, in order to change the frequency of our object, like for example, a pendulum, it will be a type of forced oscillation only. No, the force is undamped, but in order to change the frequency from 2 oscillations per minute to 5 oscillations per minute, you have to still apply some extra force to just start to kickstart the object on a higher frequency, right?
No. When you give greater hit or something like that, only amplitude will increase. The time period remains same. Frequency won't change.
But the object will start moving in a faster speed, right, sir?
Right, but time period won't change. Let it be less amplitude or greater amplitude, time period remains same. That's what even spring block system. You pull it, you give greater hit, greater amplitude, or give lesser hit, lesser amplitude. Time period remains same. It will both will come to same time to the same position, mean position, both like that, and again come back. That is the beauty. So giving greater force, as you told, only hitting and leaving. No, that won't change the breathe. This is not forced. This is to kickstart, to start the oscillation, some agency. After it leaves your hand, after you stop giving that force, from there only our analysis starts. But this force is different. This is permanently there. Is that okay? This is permanently there, and it will take that pendulum to go according to this fellow's rule. Is that okay?
Got it, sir.
Yes. Okay. Doubt in chat. Darsh, come on again. You provide heat. If you provide heat, who is this Raman? Time period remains same, but amplitude. What heat? If hit. Okay, for hit. Understood. I got it. You are right. Amplitude. You are absolutely hit when we hit it. Right. And our hero Shashwat. So the periodic force is acting throughout. Yes. That's, please don't forget that. You are right. After some time, the force causing the force oscillator becomes the maximum, dominates the remain. Yes, right. Fine. That is what the final. And here, that is. Can you tell? Siddharth's doubt once, please. What is the Siddharth's doubt? Please. How does? Oh, right. No. What was the thing is, Siddharth, then Soham, what he asked was, if we give a hit, then frequency will change. No. Give a hit, or like he means we have to give greater amplitude only we will get. But greater amplitude will not change the frequency, is the logic of Soham. Understood? In forced, okay, yes, understood. So, Pratik, in forced, it here in this anyway oscillation, when we say somewhere it has to come to rest and come back, turn back. Pratik, understood? In force also, that applied force also, the nature itself sinusoidal. That is okay. Anyway, sinusoidal, non-sinusoidal, whatever is there, but it will come to rest and then come back. Yes, no doubt about that, Pratik. Aditya, statement of oscillation on board. What is meaning of statement of oscillation, Aditya? Put F0 is 0. Darshi saying, get equation of X as the tough damped oscillation. Oh, you are saying, please wait. Permanent rest. No. This is no permanent rest. Nothing. No. It will keep on oscillating. Result itself says like this. Yes. Now wait. Atharva and even wait. Once Darsh, let me understand what is Darsh statement. If you put F0 is 0. Okay. Your question, you should get that result. That is your okay. We won't get even exponential itself. This is another situation. Okay, I understood. Okay, now, where is our Darsh? Darsh, your expectation is you put F0 0, so we should get our earlier result. Is that right? No. Okay, I understood your point. Now, I will ask you one question, like if for example, pendulum, simple pendulum, correct? What is the time period here in simple pendulum? 2 pi root L by 0, like that, right? Right. If we reduce G, somehow if you go to a place where G is reduced, what will happen to time period? It will increase. Very good. Take to some other planet where still it is less, then still G is less, then time period will still increase. Go to a place where time period is G is 0, time period will be, that she's saying infinity. Right. Correct. But really speaking, what will happen in simple pendulum? Time acceleration is not there, G is not there. Give a hit. It is phenomena itself is different. It will be 2 pi r by speed v. Circular motion. Time period is different. You understood that? Thus, it will become circular, as Satharva says. Right. Thus, phenomena changes. So sometimes it happens. So here, please, even then I will also think on this. Nice situation. But here, is it happening here also? Is another example, second example. I generally give that. Many times students immediately special case. No, start solving the equation only. That only gives another one. Because here, exponential is not only appearing. Is the logic clear? So by making a special case, plugging in the special case values, exponential cannot be brought in as such. No, that is the problem. Or in limit carefully we should see. Is that okay? Understood about that? So please. How does oscillatory motion not slow down eventually No, no, Siddharth, it is not that is, somebody is also forcing it. That you should not forget. Aditya, please wait. I will tell. Aditya, please wait. Oh, Siddharth, you understood. It is forced one what we are discussing. For force, somebody is there which is forcing the system to go in his own frequency. So everything behaves that way. Understood, Siddharth? If it is that force, that this force wouldn't be there, sine omega t, that force, then different story. It will decay. What you are saying is right. Okay, so the force amplitude remains constant throughout, and that amplitude is a new amplitude obtained by the formula here. In that, even forced frequencies, angular frequencies appearing, natural fellows are appearing, value of force is there, everything is there. Right. How can the equation of A is amplitude ray, thus it is A, and the me who decides what would the amplitude be, how much I pull the spring, that would be the amplitude. No, wait. Thus you want to speak or what? You keep on typing big thing. No. Listen. That's question is like this. That's you can such question you please type to everyone. Yeah, let others also read. That is the main advantage in such forum. That okay, your question let others also understand. Not that we should get the answer immediately. Let idea come to everyone. That okay, Anuja, what is not available? What is phi in the formula? Phi is the phase constant. Approach angle, they say initial phase constant, initial condition. Everyone's chat is disabled. Oh, in the okay, fine. Don't worry, I will read it. To chat to Anuja. Fine. Everyone in chat. Okay. Sir, option to type to every. Okay, fine. Now don't type that. I understood. And now coming to our. Could we say simple idea of forced oscillation is even after we apply force, its amplitude changes, but its time period is same? No. Time period also equals to forced frequencies oscillation only. Atharva. Now our hero, who was asking that our Darsh question is, what he says is, how much right, Darsh, how much you pull based on that only you are saying, right, Darsh? That will only decide the amplitude. Is that right, Darsh? That is running in your mind. Correct. All right. Thing is, you don't only disturb initially. That force is there externally. F0 sin omega t will start making it to go. So it will come to that A. It will come to this A. Or you only give too much of A initially. Pull it somewhere and leave it. It will decrease and finally come and settle with this A. Damping will make it to come to this A finally. Somehow all will put together, come to this stage. Understood? It is finally this damped. That we are not studying. How from beginning, how it goes and comes to that steady thing. That is transient state we are not studying. Afterwards only this result. Understood, Darsh? Okay, fine, don't worry. It is long way to go. Don't worry, you will understand. Every day, please spend some 10 minutes on this notes alone. You will start getting. Is that okay? Any difficulties? Shall we move ahead? Right? Now, listen. Next topic. Okay, one more information also I will give you. Please note that and think on that. See, when will amplitude be maximum? Is there any special thing? Yes. When the forced frequencies are, that is when amplitude will be max, when omega is under the radical. This also please accept it. Omega naught squared minus b squared by 2m whole square. Please accept. It means what? Understand this. Force the fellow's frequency and this value. Don't say it is omega naught. No. The undamped frequency. It is not undamped frequency. All put together, undamped and B put together. When they match, then this will be the situation where one will get the greatest amplitude. Then this situation is called resonance. And next is right. Fine. All right. Amaya, we will do later. Don't worry. Don't worry. We will move ahead now. Shujan. No, wait. There is yes, the system. Wait. Pratik, please maintain patience. We have to move ahead. Don't worry. We will do. Don't worry. Wait. I will. Who was asking? Yes. Shujan. Listen. System is there. So even maximum amplitude called nothing, right? Nothing. I don't know the name. The amplitude will be maximum. That's all. Wait. Now that denominator 0. Right? Please don't apply special. Please wait. First you understand and remember the result. Listen. Everyone listen. Oscillation becomes a resonance situation, right? Listen. There is a viscous force. There is anyway kx spring is there. Fine. Now your oscillatory force also is there. Now it achieves some amplitude. Fine. After some time, it achieves some amplitude A. Done. Keeps going. Done. If at all, if that omega in f sin omega t, that omega, if it would have been equal to this value under the radical omega naught square minus b square by 2m. Yes. This situation, amplitude, whatever amplitude we get for different omegas, different amplitudes. For this omega, special omega, you will get maximum amplitude. Is that okay? This situation is called as resonance. Is it okay? Understood the meaning? Don't see how it is derived, all those things, please. Remember it. Is that okay? That's Sujan, you understood? Asking for. All right, okay. Fine. Listen, students, we will do problems. Don't worry. Now we will move ahead. Is that okay? We will move ahead to next topic only. Is that okay? We will do. Don't worry. Some miscellaneous we will be doing. Don't worry. That's okay. Whatever is that, but please remember right now. Is that okay? Commit to memory. Okay, shall we move ahead? Say yes, everyone. Good. Right. Start. Right. Huh? Somebody is saying break. No. Wait, don't worry. We will break during Kushi. Damping increases with the time. Should they apply the force? No, that is different. This is different phenomena. That is different. This is different phenomena. Right. Okay. Now somebody asking break. Wait. By 4 we will break. Don't worry. We will now start new topic. Is that okay? Atharva, it is confusing. It will confuse. I am confused in damping and forced oscillation. Damped and forced. In normal oscillation, you know, Atharva? Normal oscillation. Our undamped. If you bring resistive force, it will be damped. Say yes. In more than, now it is damping. Why? Somebody may say, no, I want to make it oscillate in my own way, and he is bringing F0 sin omega t. This also is possible. So in this case, it is called forced. Are you getting? Right? Yes. Too young. Very limited sums are there. Don't worry. But anyway, we will do that. We will now move ahead. Is that okay? Don't worry. We will do that. Yes. There are good problems also. Very decent, tough problems also available. But please maintain patience. We will do that. But now we will move ahead. Yes. Okay. Now, next topic is, I will also tell you our plan for further 2-3. Please wait. Right. Listen, today and further 3 more lectures we will be spending on optics. Now we will start optics, right? 2 optics, 2 lectures, 2 days for ray optics properly. Then 1 complete session for telescope and microscope, optical instruments. Is that okay? After that, electromagnetic, moving coil, tangent, that and all later I will tell. First, we will go to, our plan is 3 more extra lectures for that is optics. Is that okay? Next 2 weeks. Next 2 weeks optics. After that will be telescope. Meaning some other subject will come, but whenever for physics we meet, it is like that. Keep this in. First, register this in mind. Accordingly, study and learn. Okay. Now, but when we start, please wait. No, this is for that regular Atharva. This is for that. This is the end of that ray optic. We will be doing this. Is that okay? In the regular lecture, no, that is the extra one. Okay? No, don't worry. Leave it. We will do it between. Don't worry. No offline batch. We will do. This is the end. So please be attentive. Okay, Yash. Let me check. Don't worry. No, we will move ahead. Yash, please. Don't worry. We will move ahead. Atharva. Which one? Understand this if we don't. For which one, Atharva? I am not getting no connection. Offline में optics, we will start from scratch. Atharva, we will start now from scratch only. Don't worry. Is that okay, Atharva? Now be attentive. mark scoring subject. Okay, mark scoring subject. Simple rules, you will get the answer. That okay? Okay. Now listen. Less of derivation, more of how to handle problems and problems. Is that okay? Please, everyone, and some questions are there. Will it be done in offline or not? No. Please be attentive. Is that okay? It will be done here only. Right. Please be attentive. We will go slow from scratch. Listen, ray or geometrical optics. We treat light as rays. It travels in straight line. Is that okay? Any difficulties? Light travels in straight line. This idea only is used here, right? Any difficulties? You would have studied wave optics, their wavefront. The line perpendicular to the wavefront is the ray. That's all. Light can be bent in, yes, that is very much possible. In vacuum, you leave it, it keeps on going in straight line, like that. Okay. Next. Here. That is object. Diffraction. No. Not diffraction. Wavefront you would have studied. Wavefront. In waves. It gives like this wavefront. In the perpendicular line to the wavefront. There wave you would have studied wave. Perpendicular line to the wavefront of the waves we call as ray. Right. Now listen. Don't worry. Come on. Oh, then don't bother. Ray, you know ray. That's all. With this we will start. Now, then leave it. Don't only use anything. Then nothing to it. Don't worry. Now see object. Types of object. Tell me. Sai, please listen. Sai, listen. Yes. Saket, right. It bends all those things, but right. Object. Now listen. It can be luminous or non-luminous. Right? Which gives light by itself. Which doesn't give light by itself. Luminous. That is sun. Candle. Like that. Which gives light by itself. Non-luminous doesn't give light by itself. Then listen. Okay, now another way of classifying point object extended. If size of the object is small when compared to the region under study, point object, or else extended, big. Right. Jnaneshwari. No, luminous, non-luminous stuff. I don't know. But please wait. Moon is non-luminous, right? Our pen non-luminous, anything, whichever luminous other than that, all are non-luminous. Okay, now listen. If, listen. Let us take a simple situation, candle. It gives light, right? Point, Swaraj, point object means if its size is small when compared to the region under study for consideration. That okay, a region under study, that's all. Right. Extended. This is your previous. Soham, which one you are talking? Soham. Extended means we cannot neglect its size. Extended. Now. Listen. Candle we will take. This ray goes here. This ray goes here. This ray goes here. This goes here. This goes here. Right. Region under study. Area of study. Right. Now. Acha, Siddharaj is saying example. Listen, Siddharaj. If I take this object, if I keep lens here, listen. If I take this pen, keeping lens here, I will get image. I cannot neglect the image size. I cannot neglect, that means object size also. Whereas if I take this quite 50 meters away, only I can locate its image position. I cannot find the image size. It will be very small. Right? Same thing when taken very far becomes a point object. Laser point. No. Don't confuse with that. Yomkesh. No, laser, nothing. This object only when you are when I'm studying in lab, keeping lens nearby, it is extended object. When I take it very far, 20 meters away, this size I won't get any size. Image size will be very negligible. Only I can position the image. Only I can locate the image position. Understood? Okay. Now listen. Long way to go. Listen. Diminish. Very small. Its object size is of no use only. Okay. So we can neglect it. Then done. Okay. Now listen. Candle gives rays, right? If you collect it, will you be in a position to see the image? Yes or no? Candle image? Candle's image? Yes. Who is responsible for you to see the image? It is the set of rays entering your eye, right? Okay. Now see, they collect the rays here. Here. Can you? That is here. If can you see this image of the candle? Yes. Very good. Now we will bring a mirror, plain mirror. We are keeping it here. What will happen to we are start doing from scratch only. So nothing like we should have studied prerequisite. We should have studied or some nothing. From basic we start. Is that okay? Say yes, everyone. Say yes. This is our beginning. It will be easy. By knowing the sign convention, you can manage many problems. Is that okay? So mark scoring subject, small topic. Now listen. You are bringing a mirror here. So what will happen to the rays? What will happen to the rays? They will get reflected, right? So we should know how they get reflected. So we should understand law of reflection. Laws of reflection. Two rules. Laws of reflection. First rule says angle of incidence is angle of reflection. Second rule says incident ray, reflected ray, and normal, they all are coplanar, all lie in the same plane, right? So we can now apply law of reflection. Put the normal to the mirror. Yes, same angle as this one, right? Here, like this. I, it goes here, comes back. I is 0, so R is 0. Here, here it is. Right. Now see, can you see all these purple colored rays? They are all reflected rays. Yes or no? Right. Now, if you stay here, will you be, are the rays entering your eyes? Are the rays entering? Yes. So will you feel something? Yes. It will make you feel as if rays are coming from this location. Yes or no? Right? So this, like this is called image point. Image point. For this one single point, there is another single image point, unique image position. Virtual, that we will do it later. Shreyans, later. Yes. So like this, for another point, you will get another image position. Another point, you will get another image position. So if you see, you will get image like this, right? Shitish, important question, our Shitish. Now, oh, it is 4. Okay, okay, 2, 2. Okay, now listen, it is 4 now. We will meet by 4:15. We will take a short break and we will meet at 4. Who is that? Anuja? No. 4:15. Only 15 minutes break. Then after the break, we will again start with this one. Then image distance we will understand. Then we will keep doing problems. Is that okay? We'll start with problems. Don't worry. Is that okay? After this, many problems of plane reflection. Then I will tell you breakup also. Don't worry. Is that okay? Listen, charge, please. No. Now it is for okay. No. Please assemble for 15 or 4:20. It's okay. 4:15. Is that okay? Fine. Previous slide. Yes. Those who want to take break, please leave, but come by 4:15. Yes. Which diagram, Rashid? Forced oscillation. Diagram of candle. Okay. Only 10 minutes were. Yes. I also want to take break. We will discuss later. Who was that? Explain the meaning. Atharva, we will discuss it. Don't worry. Don't worry. right? PDF I will somehow send it. Don't worry. Then no, Shreyans, no, not available. By exactly by 6. Okay, don't worry. Now we will stop. Is that fine? Okay, now we will meet after the break. Please, whatever doubt you keep in mind. We'll discuss. Don't worry. Right, okay. We will break. Fine? Yes, thank you. We'll meet after. We'll meet by 4:50. Yes. I don't know, Anuja. I don't know. We will meet, please. I will discuss later. Don't worry. Yes. Welcome back, students. Yeah. But how do I do that, our Ayush? I don't have that permission. I am not the host. I am the host, yes. Then what have you taught after the break? Now only I started. But you tell me, how do I give that permission for? From where do we do questions for? See our 49, that 42 years, 42 or 41, whatever that year's book only. Directly see from there hereafter. Right. Now listen. Come on. No, I don't have that. I don't know how to give permission for that. More. Yes. Okay, the meeting setting. Okay. No, okay, fine. Don't worry. I will read for time being. I will read your questions also, so that others also will understand. We will see. I will also inform her. Don't worry. Inform the madam. Yeah. Listen. Welcome back. We will start now. See here. Rays, many rays from the source keeps going. After they go, they get reflected, gets reflected. With what rule? Obeying law of reflection. Is that okay? Right? So now, if you collect these purple colored rays, you will feel as if rays are coming from here, right? But this is not object, so this is image, right? Now, don't say source behind mirror. Say it is image, another name, non-object, image, right? Now, listen. Right, it will look like that. So it's not the object, so it is image. Fine. Now listen, everyone. Listen. See, if some curve, okay, no. Okay, we will take these two triangles. And this. When you take those two triangles, this is 90-90. This angle is equal to this. This will be equal to this. So this and this are equal. So this angle will be equal to this, right? Also, this side is common to both the triangles. So these two triangles are equal. So this distance must be equal to this distance, right? Yes, yeah, whatever is that. Yes, they are equal triangles, congruent triangles, right? So object distance and image distance both are equal. Image distance is equal to object distance. Any difficulties? Remember this rule. Memorize this rule. Image distance is equal to object distance. Any difficulties? Say yes. It means, now tell me, if there is a mirror, there is object kept here in front of it, where then image will be that much distance on the other side, right? Here will be the image, same distance, right? If mirror would have been here, and if object is in front of, not in front of the mirror, will image get formed? It will still be there. Only thing is, ray will go here, get reflected, it will go there. Ray going here, gets reflected, it will go there. So if you collect these rays, you will feel as if image is, that is, rays are coming from here. This is image. This is object. Understood? Image distance. This distance is equal to this distance, right? Object distance equals image distance, right? Only thing, object cannot see the image. See its image. Any difficulties? Right. Shall we move ahead? Shall we move ahead? Now one question. Aditya, listen. If object is given, even if mirror ends here, what you can do is take the ray, apply I equals R, get it here. Ray I apply I equals R. So if you capture these two rays, you will feel as if they are coming from here. That okay, this ray will come, it will go here. If you extrapolate, it will go back. So you only thing is the image will get formed here. Only thing is you cannot see your image. Somebody else standing in this region can see your image. Is that okay, Aditya? What will object see? Nothing, Ray. It is like this. You are in a room. You are in a room, but only here mirror is there. Is that okay? Then if you stand here, you can see your image. If you come here and see your that is seen this mirror, you can't see your image. Somebody else standing here can see the, sorry. Understood? It will be, but if you want image location where if this is object, that image will be here, no doubt about that. Understood? Only thing you can't see your image. Right? Understood? Next. Next is, right, one problem. Okay, I will tell even the, first we will do one problem. Yes. Okay. Yes. Man keeps moving parallel to the plane of the mirror. Mirror of finite size, as shown. Plane mirror of finite size. Object is kept in front of the mirror as shown at a distance L1. Now, for what is the maximum time for which this person can see the image of the object in the mirror? Okay. Shall we try? What is the visual angle? Darshi is telling something. No. Yes. Atharva. This is the first question after break. Darsh. Root of h squared plus no Sharva. L1 plus L. Yes. Right. Atharv, even you have to get the time. Right. Atharva, no. Okay, now listen. Okay, where will the image be? Right. Listen. He is interested in seeing the image. Okay. Ashwin, are you there? Now, Siti, listen. Siti, are you there? Siti. Question is like this. There is a mirror. There is a mirror. Why this paper? Ashwin, something is getting typed. Ashwin, are you there? Okay, now listen, Sitish. See, you are walking like this. Here is the mirror. Here is some object. If you keep moving, will you start seeing the image of this object somewhere? Sitish, will you see image of this object in here in the mirror? Yes. If you can see it, then if you keep on moving beyond some distance, you will not be able to see, right? Beyond some distance, you will not be able to see, right? So what is the maximum distance we can see? That we can get first. Before some point, you will not be able to see. After some point also, you will not be able to see. We will get that distance where we will be able to see the object. Afterwards, we will divide it by speed. We will divide by speed, the distance by speed. We will get the answer. Even Soham, you are, I think, right. Many have given the right answer. Okay. Now listen. Here, first we will get the answer, that is image location. It is here. From here, where and all if you stay, you will be in the position to see the this is the region. First, we will get the text. How to get it? Listen, this is L1. So we know image distance is equal to object distance. So L1. This we know as height h. So we will use proportionality theorem L2. So x by h is L1 plus L2 by, for h it is L1. Therefore, X is L1 plus L2 by L1 into H. Therefore, time is X by, time taken X by V, right? So, which is L1 plus L2 by L1 into H upon V. This is the answer. Any difficulties? Any difficulties? Why 2 is there? 2L1. No, no, no. Shrey, no. T by U. But what is T? T we don't have. Ameya. Listen. See. If you, Ameya, are you there? Soham. Sahil. I take X by U, all those things, right? Okay. Listen. Are you getting the fact that if object is here, image will be here? Length, same length L1. Yes or no? Then it means join the boundaries. And so ray will come here, just get reflected, it will go there. This ray will come, get reflected, it will go here. This will come, get reflected, go here. This will come, get reflected, go here. This will come, get reflected, go. Are you getting? So, if once you cross this point, you will be able to see. Once you cross this point, you will not be able to see the image. Are you agreeing this or not? Right. Now see, if that is the case, let us try to get this distance divided by speed with which we move will give you the time. But this distance, how to get? We can use similar triangles. X by H is L1 plus L2 by L1. Is that okay? Similar triangle. Is that okay? How you got the, if two triangles are similar, even ratio, this by this is here again, this by this, or this by this, right? Sahil, where you are not understood, Sahil. That is okay, kinematics. After getting the total x divided by speed with which he walks will be the time. BPT, proportionality theorem, right. Whatever, please, tell you want, you tell, but that is a true statement. Now, Shivam understood why we are dividing. Sahil understood why, understood or not, Sahil? Now, Aditya saying it interesting. Sahil, listen, Sahil. Now, if you have object, get the image. It is this ray. If you extrapolate, you will feel as if it is coming from here. So the worst ray will be which just touches this and goes. Fine. You won't get ray from here after reflection, but falling over there. No. So here also no. So here also no. So this distance by this distance will be this full height by this. So we can get this distance. Once this is there, we can divide this distance by speed so that you will get the time. Yes. How big is L1 near? You again, two triangles are there. Okay. Listen, I will draw the two triangles separately. This is height h. This is L1. Another triangle is x and height is L1 plus L2. So x by h is L1 by L1 plus L2 by L1. Understood? Next, we can draw two similar triangles. Right. Many ways of thus we will go fast. Don't worry. Now next. Then next. Next question. Simple question. Mirror ray I, it will get deviated. Ray gets deviated. Angle of deviation fast. Yes. Who is this boy? Oni Chan. Listen. No. If a ray is sent like this, after reflection, it will go like this. How much is the deviation? That is the question. Right. Very good. So it is I, this is I. So total 2I plus delta is 180. So delta will be 180 minus 2I. Memorize, commit to memory. Shall we move ahead? Next. If. Okay. Shall we move ahead? Fast. Delta is deviation. Right. Haram, as previous slide. Okay. Take screenshot, no problem. right? At the end, I will show you. Don't worry. At the end, I will keep on showing. Yes, yes. Please wait. And even I will give you this PDF. Don't worry. Now, next. Right. Horizontal, horizontal, horizontal. Two mirrors are inclined as shown. What is the theta, so that the ray, after third reflection, it will start retracing. The ray starts retracing after third reflection. 45. Many are telling 90. Rutu, 45, 45. Satak, 45. Sita. Very good, very good. Atharva. Right, right. "45" is wrong. Most popular wrong answer. 16, no. Sarthak. Okay, listen. Now everyone listen. Now, no, listen. If a ray is right, it comes here, hits, and goes back. If you take this theta, this will be theta. So 90 minus theta, 90 minus that, this is theta. So theta plus theta, 2 theta should be 90. Theta is 45. But this is wrong because it starts retracing after first and second reflection. Right. So this is not right. So we have to again draw. Yes. Now see, ray keeps coming, goes here, then goes here. Please wait. I will draw proper. That means ray comes like this, goes like this, then goes like this and hits here. Theta, theta, theta. Now see here, remote exterior, theta and theta, 2 theta. Then this is 2 theta. So total 3 theta is 90, theta is 30. Understood? That means answer is here first reflection happens here, second happens here, third happens here. So if you want for fourth, what to do? After fourth reflection means what do we do? First reflection, second, third, fourth. Understood? Theta means theta. Right. Theta, this is remote exterior. Theta and theta, 2 theta. So this is 2 theta. So remote exterior, 2 theta and theta, 3 theta. So 3 theta plus 3 theta, 4 theta is 90. Like that it keeps on going. You can generalize it and write. N theta is 90. Okay. Next, shall we move ahead? Yes. Then do. Shantanu, yes. See, listen. Steps. If Shantanu, listen. Remote. Okay, it is like this. In a triangle, this is called remote exterior for these two. Or for this is called remote interior. Remote interior, or for these two, it is remote exterior. Understood, Sahil? Now, shall we move ahead? No. Retracing means it should hit perpendicular, then only to retrace. Wherever retracing happening, it should hit perpendicular. Then only from there onwards, retracing will be there. Understood? For formula for finding theta, Suyoga. Theta we use n theta only for all acute. Yes. True only. Right. Now listen. Suyog, where do you face problems? Suyog. 45 is true in wait first I'll finish with no, our side 45 is wrong, because it here the first reflection, second reflection, here only it started retracing, going back. It comes here, it started going back. But in this case, such is not the case. It comes here, goes here, then from here onwards it comes back, goes back like this. Are you getting? Our where is our Suyoga? Understood. So if by fully geometry, if you say this theta, this will be theta. So anyway, this is theta. Theta plus theta should be 90. But the thing is, this is not true. But it will retrace, but not after that is the third reflection. It is after second reflection. So we need first here, then second, not only here, third. Here it is retracing. That is what is happening here, then here. It comes back to understood, Suyog? Understood? Right. Next, Kanishk. Number of reflections, right. After which it should start retracing. Next, 2 mirrors given. Two mirrors given. I will say it is theta. Object skipped. Number of images. Number of Aditi, please wait. Aditi, follow. I will tell you. Don't worry. Now you keep following. Vedant, number of images formed. Theta given number of images. 5. Manshu 360 by theta minus 1. Says 360 by theta. Okay, 5. Okay, listen. I will give the result. Commit to memory. Can be proved, but slight labor is involved. Now listen. What if theta is given? First, get n, which is 360 by theta. Then, if n is even integer, then answer is 360, that is n minus 1. Okay. Next, if n is odd, if n is odd integer, then two cases. If answer will be n, if object is not on angle bisector, which will be n minus 1 if object is on angle bisector. If it is fraction, fraction. So it is take integral part. We will take example and see. Listen. Listen. N is that number. Like say, if this theta is say 60 degrees. Now see, if N is 360 by 60, which is 6. This implies it is even integer. So answer is 6 minus 1. 5 is the answer. If we take theta as 72 degrees, now see N is 360 by 72, which is 5. Now you can't answer. You can't answer. You have to ask question. Is object, two cases are there. Object is on angle bisector. Then answer is 5 minus 1, 4 is the answer. Object not on angle bisector. So it is 5 will be the answer. Like that. Then take theta as 25. So N is 360 by 25. What is that? 4, 3 is 12, 13, 14, and 350, 60 by 25. So it is, answer will be 14. Take only the integral part. Any difficulty is understood? Understood? Everyone understood? Right. Now, if object is on angle bisector, subtract. And yes, provided answer should be that integer, integral. Right? Fraction means take integral part, wherever be the object. Right? Object is an angle bisector. Okay, and that is okay. You can interpret like that. Okay. Right. Shall we move ahead? Why not? This proving becomes difficult. That is why. Not rounding off. You won't get part of the email. No. That okay? Shall be right. 14.999. It will be 14 only, Arpita. Don't round it. It means till that angle corresponding to this 14.999, there is no image. Afterwards, when you come only, you start seeing it. So don't do that rounding job here. Angle bisector means what? Angle why mark angle Soham? Why the angle bisector is this is the angle. So half of that. This is the angle bisector. Why? How can one decide whether it is it will be given. Without that, you can't solve. Right? Okay. I divide the angle into 2. Yes. Okay. Now listen. For us, which example? Take 25. Is this your the third one? Take 25 degree. If angle between them is 25, then how many images will be there? So take 360 by 25, divide it, you get 14 and 10 by 25. This is fraction part. This is integral part. Answer is 14. Greatest integer. Okay. Okay. That is right. Agreed. You can use that here. Right. Okay. Shall we move ahead? Next is speed and all. You should understand the that is speed related stuff. When you move like this, say 5 meters per second, scroll back. Raman. What was the answer to the previous question? Which one? Previous question means Shrey. This one 3 is the this is the answer, right? That T is the answer. Answer. Okay, listen. If object goes parallel to the mirror, image also right to find number of images. Okay. Shrey, which one? Answer is this is the many cases are there. So there is no one single answer. If the angle would have been given, one single answer will be there. What if 3 mirrors? If they are perpendicular, we can still mutually perpendicular, we can tell. Or else it becomes complicated. Yes, kaleidoscope. Yes, like kaleidoscope. Complicated only. Many mirrors. This fellow's image there on that, next, like. Understood? Becomes complicated only. Right? Yes, very much possible. 2 parallel mirrors you keep, image will be infinity only. Infinite, right. Doppler effect observed in different. Yes. Doppler effect. Okay. If object keeps moving parallel to the mirror image, speed is same thing. If if object moves perpendicular to the mirror, image direction changes. Anuja, yes? Shreyans, okay. If object, see if object is at rest, if mirror moves with some distance, what if the mirrors are perpendicular to each other? In which case, but what is the question? Ram, mirrors placed perpendicular. You want to find number of images? Ram is saying what if mirrors are placed perpendicular? Then the answer is 360 for 90. Answer is, okay, that is n is 360 by 90, which is 4, even integer. So answer is 4 minus 1, 3. Right? And now coming here, if mirror moves, image will move with 10 meter per second, 5 into 2. Okay. Anuja, which one you're talking about? Anuja. Anuja. No. At least we can do for what is that? Even. And it can be done for. Generally, we do, but not in this forum. Difficult. No time won't be there. Let us move ahead. If time is there, then we will revisit later. Don't worry. Not necessary. Both mirror need not touch. Is it that they should touch or what? Please wait, I have to read. Front of the image will appear to be twice. Right, wait. Two mirror, the case we took right now, we got image speed as right. It is, no, it is all image speed with the ground. Object speed given with the ground. How will speed be 10? Can you explain the third case? Sitej, which one you're talking about? Speed. You're talking about the speed. Sitej, are you talking about the speed? Okay, then it should be proved. What you can, okay, we will, please wait 2 minutes, we'll prove it. What you can do is, listen. You can take this as something like P, where image will be here. So this, okay, we will not take it as, it can be proved easily by making it X, shifting X, then getting the final position and differentiating. Better we will take different route. If it is 5 meter, how much will be this? 5 meter. Are you agreeing? If mirror moves in some time here, even image will come here, right? Right? That means if time taken by, that is in the same time, image travels double the distance when compared to the mirror. So it must be twice the mirror speed. Understood? Understood or not? Who was asking for that? Wait. Aditya. Listen, Aditya. See, here is the object. Okay, Aditya? Siddharth, listen. Here is the object. You are standing here. Mirror is here. Okay? Where will your image be? 5 meters behind. Agreed? Right. Now, so image is how far from you? 10 meters. Right? Now, you bring the mirror from here to here. From mirror, which is 5 meters from you, you bring it near you and let it touch you. So, where image would have come now? Where will image be now? It would have, that also would have traveled and it would have touched you. So when you touch the mirror, image will touch. So image which was 10 meters behind you has come is touching you. Mirror was 5 meters from you, which is now touching you. So that means mirror would have image would have traveled double the distance. Moving the mirror by x, move the image by double the distance. Yes. Right. Next, if all are moving, then only problem. Please move to mirror frame and solve. Will help you. And finally, you come out. Understood? Now. Right. What will happen when mirror is no problem, Ray? Mirror accelerates means then you have to do that twice the accelerator. Okay. What you do, this itself how to prove. By constraint equation, you can prove it. See, here is image. Call it P. This will be P. So let us move it by X. So new distance, object distance will be P minus X. New image distance will be another P minus X. Is that okay? I dash. Now, how much image has got shifted? Which is total distance is 2P. 2P minus this distance, P minus X and P minus X. 2 times P minus X. So it is 2X. So this displacement X2 is 2 times X. Differentiate X2 dot is 2 times X dot, done. 2 X dot is mirror speed, right? If both moves prefer going to mirror, say one example only we will take, any number we will take. This moves with 2 meters per second. Here object moves with 10 meters per second. Like this, big question. Then anything can be happened. What to do? Go to mirror and solve. So it will be, object will come towards with 12 meters per second. So now see the image. When you turn inside and see, it will be like this, 12 meters per second. Velocity of image with ground. Now what we want to please get it, na? Is it image as a image, not the ground? Image with the mirror. Image with mirror. So velocity of image with the ground will be velocity of image with mirror plus velocity of mirror with the ground. Do it. Not a big deal. So image with mirror is 12 and mirror with ground is 2. So it comes to 14, I think. Right. Shall we move ahead? 12. That, listen, here only, na, 12. When you are in mirror, whatever object speed you see, image speed also will be same thing. Right. Right. Saurabh. Right. Okay. Now listen. Very, very important. We are understanding what and all will be done. Now, reflect. We are in reflection. Then refraction. In reflection, two types. Plane reflection, then spherical reflection. Here, plane diffraction, spherical refraction. then 2 times that is refraction, which is lens, then prism, two plane surfaces but not parallel to themselves. Everything is in our curriculum, so we have to wind up everything in these many, and then we have to move to optical instruments, right? Shubhashri, done. Okay, now listen. Spherical mirrors. Last to last. Atharva Saurabh. Last slide is this. Okay. And we please wait 1 minute. Right. Right. What is S? SPN PL? Spherical ray. Spherical. In reflection, spherical, plane and spherical. Refraction, plane, spherical, and the lens and prism. Done. Done. What is yes in last question? Where is yes? Yes नेरे वो 5 है. आउजा. Yes नहीं है वो 5 है. See, it is mixed level. Don't worry. We are understanding. Then you can do any level. Don't worry. Right. Now spherical mirrors. Yes, do that. Ram and Ahuja, something you're asking. Anuja. Is the VIS1 image with ground ray? Image with ground. This is mirror with ground. G means ground. Image with 10 and 2. Here per second. Now spherical mirror. Okay, before we move here, we should understand types of images and objects. Image, real, virtual. Object, real, virtual. Then it is not yes, it is ground, comma, Tanvi. Now, image, real means rays converge to form. Virtual means rays diverging from the image. Real object means rays diverge from that object. Virtual means rays converging. Right? It is, how can object be Shreyans? No, by nature, you will not get it. By nature, you won't get. But for example, if here is object, you are keeping a lens. They meet here. Now tell me, what is the nature of object? Real object, because rays are diverging. This is real image. Now if another device is there, nature virtual, I don't think it is possible. No, dash. Now like this, like if this goes, this is the next object. What is that? Real object, O2, and here image is getting formed. This is real image. But now listen, if you bring this here, slow here and leave it. Now for him, who is the object? This is the object. Nature of object, virtual. The moment it comes from here to here, rays, they are diverging to form that object. Whereas here, from here object, it is diverging like this. Here it is converging to the object. So this is virtual object for this lens. Is that okay? Right? Understood? Now, shall we move ahead? Shall we move ahead? Excuse me. Hello. Now, shall we move ahead? Right. Complex compound mechanism. Okay. Right, no problem. You will find many situations. Even while solving problems, we will come across. Okay. Now listen. This is one thing. Next, we have to understand Parth. Parth wants to understand the listen. Object, Parth, real object. For this lens, real image. Okay, Parth. O1 is object real. This is real image. Right? For this will be serving as a real object only. Rays are diverging for this lens, right? Rays are diverging from here. Image of first earlier fellow will be object for next fellow. Don't forget that. Remember this. So for him, he is object, real object. But if you bring this lens and place it here, for him, For this fellow, image is here, but that is object for him. This is object for him. So rays are converging. So that means now it is forming real. This is now, this one is now virtual object for this lens. Virtual object for this lens, because rays are of converging type. But don't misunderstand saying that ray will come here, it will go here, it will come back, it will come, nothing like that. It will go here, come here. But rays are converging type over here. So this is virtual object. Understood? Next, we have to understand the paraxial rays. Paraxial rays means nearly parallel rays. They need not be parallel to principal axis. See, this is parallel ray. It is paraxial. This is parallel. It will also qualify as paraxial. But too much away you come, it won't form image properly. And that okay, it won't meet after reflection. It won't meet here. So it is not paraxial. At the same time, if this is not a parallel ray to principal axis, but it is paraxial, nearly parallel rays, that's all. They themselves nearly parallel, or even nearly parallel, not parallel to principal axis, but still okay, less angle, like that. Actually speaking, we will not derive, I will give the result. But if you see the derivation, they will be using sine theta is theta, is tan theta. This rule. The rays which are subjected to this approximation we call paraxial. That's all. 10 degrees, maximum 10 degrees, like that. Yes. See, when you take a mirror only like this, this and all in book they are giving like this. It is exaggerated view. Exaggerated view. That okay, it is all quite far. Then and this angle and all won't cross 10 degree only. Theta is very small. It need not be incidence. It can be even reflected. Theta is not very small. No. Okay. Now coming to our no, the paraxial rays need not be parallel to themselves. Ipun. Okay, I will send. We will at the end only. I will remind me. I will put in this group only if you want. No, they are not parallel. They are not parallel to anyone. They are the rays which can be subjected to the approximation sin theta is theta or is equal to tan theta. Those rays only paraxial. They need not be parallel to themselves also. They need not be parallel to. They need not be parallel to the principal axis also. Nothing like that. Understood? Theta between okay, is in wait for beta theta. No, okay. See, when you derive the mirror formula and all, you will get all geometry. Sometimes you will get that is sin theta you may get, which you may be required to replace as tan theta. Or theta may be required to be replaced as sin theta, tan theta. Is that okay? When you do like that, whichever rays you can apply and get, yes, they are only this one called as paraxial rays. The rays for whom we can apply sine theta is equal to theta equal tan theta approximation, those rays only are paraxial rays. Without approximation, then if you want, formula will be too complicated. You won't get 1 by u plus 1 by v is 1 by f. It won't be so simple then. Too much headache. You have to use an angular form. You see the derivation. You will get alpha plus beta is 2 theta. That alpha only we write as 1 by u later. AP by OP, like that we will write. We are not doing. That is why you please go through HCV. It is there in HCV. Derivation. So simple derivation. Right. Paraxial maximum 10 degree. Yes. Theta is angle. It can be angle made by C. Okay, listen. Listen. Please listen. Mirror. I'll tell you who is that. Which sign? Please, okay. Please wait. Theta is angle. Anuja and Sharva. Please wait. Okay. We can take a mirror, rough center, approximate center, call it pole. This is pole. The center of the mirror, C. Radius of curvature. Line joining pole and C, principal axis. Parallel rays when sent, they will meet the principal axis. Focus. Right. Plane passing through F and perpendicular principal axis. Focal plane. Distance between focal point and pole. This is called pole. So this is called focal length. These are all the standard terms, right? See, I will tell you. Okay, since you people are asking paraxial, listen. Let us take one object here. Okay. Here is F. Here is C. Take this ray. It will come hit. Yes. At the end you ask, no bro, remind me. Right. Aditi, listen now. Now we will get the normal. Call it theta, say. So after reflection, it will come here. This is another theta. I equals R. So this is the mirror. Right, Aditi, and those who want to understand that paraxial, those who are asking theta and all. Anuja, Aditi, yes. Now it will meet here. So this is the image. But call it alpha, call it beta, call it gamma. Now see, what will be gamma? Are you agreeing gamma is alpha plus theta? Gamma is alpha plus theta. Same way, beta is gamma plus theta. Beta is gamma plus theta. Now see, we don't want theta. We will get rid of theta by subtracting. Gamma minus beta is alpha minus gamma. So alpha plus beta is 2 gamma. Right? Now see. If somebody gives you object location in terms of alpha and in gamma, if it is given, can you get beta? Can be. But very difficult to, how will you interpret this? This is angular form of mirror formula. You don't have any use of this. That was very difficult to use and all. Then what to do? See here. Call it P. We will convert, since this is all exaggerated drawing. exaggerated drawing. So we will generally work for such small angles only. So instead of writing it as alpha, we will write it as tan alpha plus tan beta is 2 times tan gamma. So that tan alpha is what? AP by OP. Tan beta is what? AP by IP in the drawing. Is that okay? AP by IP. Then tan gamma is what? AP by CP. So this gets cancelled. See here, we are getting mirror formula. 1 by OP plus 1 by IP is 2 by CP. Is that okay? This is here you can measure OP, you can measure IP, you can measure this. Yes. So here we have used this angle, this approximation from here to here. So we can do that for only such rays. We can't do for this angle. This and all slightly exaggerated to make you understand. Drawing is made like. Is it okay? This is 1 by U plus 1 by V is 2 by R. Understood? Aditi. And I think some who was asking for what is the angle, and Aditi, right? Anuja. Okay, now listen. If you further substitute by the value what U, V and all as that formula, object formula, object distance, image distance, then you get 1 by U plus 1 by V is 1 by U plus 1 by V is 2 by R, which is 1 by F. Right. So this is called mirror formula. Right. Now listen. In mirror formula, you have, if you want to use this, use sign convention. Incident, so simple. Understand carefully. Very, very simple. Same rule everywhere. Even spherical diffraction, then lens everywhere. You easily get the answer. Is that okay? So any ray which is nearly collinear to be principal. What is that collinear? No, collinear for points only. No, Ashwin. The rays which are, yes, see, listen. Like this. This also is like this, all are paraxial. But don't go too much away. No. Who came from where? That is what. Okay, please. We will move ahead. Not a big deal. Please, when object kept at infinity, where it will focus will give you the result. You make this infinity, automatically you get IPS CP by 2. That IP we call F. Now please don't bother now. Now don't bother. Right? Remember this. Commit to memory for time being. Later we will discuss. Any doubt will be addressed. Don't worry. Is that okay? Right. See, in incident ray direction, treat as positive. Pole, treat as origin of number line. That's all. Please substitute the coordinates for U and V. That's all. So simple. Is it okay? Remember the sign convention. Incident ray direction positive and pole is treated as origin. Then principal axis, principal axis, that's going to be a number line whose pole and its origin is matching. That okay? That's all. You can keep getting the answer. Huh? So nice rule. Listen. We all are that object design. Now we will do one problem at least we will do. Wait. So that you can, this week you can keep solving whatever problem related to whatever we have done. Any difficulties, please. No problem. Don't worry. Right. One question. A meter stick is kept along the principal axis of concave mirror of radius concave mirror of, I will give focal length of 10 centimeter. The closest point, the nearest point then the closer end. The closer end of the scale or stick is 20 centimeter from the pole. Find the image length. Right. U, object distance. V, image distance. U, object distance. V, image distance. Object distance, image distance. Right. At the end, I will show. Please wait. Now. Come on. Keep moving ahead. Homework for us. This is the question. Yeah. Neeraj, final answer. Hey, homework, please. Start for plane and spherical, but this time you will find difficulty. Next time onwards, you will get enough problems from your 42 years. Please directly see solved examples of HCV and then 42 years. You should get. Don't worry. Please, Ram, please wait 2 minutes. Let us finish this problem. One by 120 centimeters. No. That also please see from your 41. The 42. Yes. Gaurav. We will do one problem of damped one. Don't worry. Previous JE question only. Very nice and good question. First, read it and get it settled. Okay, now listen. How do we do? Wait. We will do this problem collectively. Listen, everyone. Listen, mirror. like this. Now listen. Let us say A and B. This distance is how much? 20 centimeter. This is focal length is 10 centimeters, right? Yes, yes. Now listen, everyone, towards the screen. First, we will get image position for A. Is it okay? Is it okay? First, we will settle for A. Ray from here will go from left to right. So in this direction, this is positive. This is your origin. Hole is origin. That's all. This is your origin. This is positive. So can you now write the coordinate of any point? That's all. This is how you should do. Now for A, 1 by U plus 1 by B is 1 by, that is F. Tell me 1 by U, object distance. We are doing for A. What is the coordinate of this fellow? Number line, code -20, that's all. Anything sign convention means it is usage of number line, coordinate geometry. -20 plus 1 by V of A is 1 by focal length. When a parallel rays are sent, rays meet here backwards. When a parallel rays are sent on convex mirror, they go and meet here. So focal length is positive for convex, focal length is negative for concave. So here it will be what you only tell, -10. Focal point is here, its coordinate only, -10. That's all. Please solve for VA. 1 by VA is -1 by 10 plus 1 by 20. So take LCM. So 200 -2 plus 1. No, sorry, 20. LCM is 20. So which is -1 by 20. So VA is -20 centimeters. Now you interpret it accordingly, right? So it is again 20 centimeter, the negative side. So here is the image. Here is the image, A dash, right? It is image is forming on the object only. Why is it so? Because F is, R is 2 times F. 2 times F is 10, 20. So object is kept at the center of curvature. Ray which is going here will hit normally, come back. Hit normally, come back. Hit normally, like that. So there is no need for solving if you first only, if you can judge that, anticipate that. You have to observation skill. You have to carefully see whenever you solve problems. Is that okay? They would have given even a simple, that is the situation. Now, listen. We will do for B. Tell me what? Let us take different color. B. Now tell me for B, incident ray direction like this. This is possible pole. That's all, right? Now you only tell 1 by what is coordinate of this 1 meter length, 100 centimeter length. Very good. -120. Wonder. So -120 plus 1 by B is VB is 1 by -10. So 1 by VB is -1 by 10 plus 1 by 120. So 120 minus 12 plus 1, which is -11. 11 by 120. So VB is that is -120 by 11. Approximately 11 centimeter we can take. approximately 11. So all the rays will come and minus 11, minus 11. So interpret it carefully. Interpret it carefully. So it meets here and minus 11 here. They all meet here. Image. This is B dash. So image length will be here. Image length is therefore A dash B dash is 20 minus 11, 9 centimeters. Any difficulties? Understood or not? That's distance between A and B. That's all. What if stick is vertical is another question. Who is asking Shishi or something? Yes, it is. It should be. You have to handle it by magnification. Horizontally kept along principle like this. Vertical means magnification. We will do that. We will do that. So subsequent lecture, we have to wind up mirror. In the first half only, we will settle to plane refraction. Then in the second part, we will, at the end, we should touch spherical refraction. So that next, that whenever optics lecture comes, lens and prism, we have to finish. Then we will come to, go to instruments. Is that okay? Screenshot out. Okay. What to take the, yes, please wait. I will show you. Then I will give a PDF also. I will try to upload here on. Please. Smart board. A normal board. For normal board. Normal, you can erase it. Nivesh. Oh, Nivesh, how are you? Nivesh. Good. Ram, very good. Our hero Nivesh. You understand Hindi. समझ में आता है. Which batch you teach? No, online batch. Don't worry. All these slides from starting. Wait. Who is this hero? Swapnil. Should I give a show like that or shall I upload it at night? Right now only I will put in this WhatsApp. That link. Anyway, which is okay. Or take. Soham. When will the wait, please wait 1 minute. That I will put in the chat box. Before that, those who want to take snapshot, please take. Or else you people keep on. First, I will wait for 5 seconds. I will go backwards. Come on, start taking. Those who want, please wait for 5 minutes. PDF. Yes, sir, Ram. Yeah. Varad, please wait. You people can leave. Those who are done with can leave. Those who want PDF, they can wait. I will upload it. Please wait. Please wait. Please wait. I will upload it right now. Please wait. That's saying. Wait, I don't know. Please wait, please wait. Now, this is the, wait, please. Now, no. Yes. Right. 1 minute, 1 minute, 1 minute. Yeah. File upload. Desktop. I PDF. Now, need the link, right? Get link. Anyone with link? Copy link. Done. Now, wait, 2 minutes, I am putting. Now, in the Moody, no, 5 minutes. Okay. Now please open and see. Could you people open it? Then fine. Done. No. Okay, that's all for today. Unable to copy. I don't know what is it. Nice day opening the new. Yes. Now, any questions? Somebody are telling yes. Those who are done with, please you may leave. No problem. Some questions somebody are asking. Yes, sir. I'm fine. Unable to copy. Nikhil, why you want to copy? You simply download, na? Nikhil. Can you please derive for me the magnetic field at a point distant r from finite current carrying wire using Ampere's law? It can be done. For segment, you cannot do using Ampere's law. A segment, a ring, axial point ring, it's a limitation. Right? Ampere's law is true, but you cannot do that. Symmetry is not there. Are you getting? For long wire you can do, but for finite you cannot do. That is the problem. What to do? Limitation. Law is true law, but you can't use it. Is it okay? Allow me to unmute. Darsh. Yes, Darsh.
Hello, sir.
Anuja, sir, you good in maths also. I keep it, Anuja. Yes. Then yes. That's come on.
Sir, can you hear me?
Yes, I can.
Sir, we took a finite current carrying wire and we constructed an Amperian loop around it. And then we wrote the equation integral B dot dl is mu naught into In. For all points in this loop, B is constant. It's symmetric about the wire.
You move the ring slightly above, parallel, keeping the axis parallel to the current carrying wire. How is that and this different? It is same now. So what answer you will get? It is not. If the segment would have been very long, then become wire. Then parallel, if you move also, there is no problem. Okay, you can agree that these two must here or there, everywhere it is same. So whatever answer we are getting is correct. Understood?
But is there any wrong in writing this equation integral B dot dl is mu naught In for this finite wire?
Why not? Why not? If you parallelly move it, then it won't be next ring won't give you the same result. Can we take this as counter? I will think and let you know. Okay, that's next time. You please remind me.
Because if you move that loop, if you give that reason of moving the loop up and down, if you give the reason we cannot apply because if we move up and down, the magnetic field would be different.
It is different actually. It is different, but now can this alone be taken as a point for that is contradicting that? Not that. Then For a segment alone, you take. If you take only segment, magnetic field lines will be concentric. Huh? You take a concentric only. It will be like balloon that apples. It will go in concentric only. You can take it as that boundary, then that membrane you can take. Should plunge in. Okay, I will think and let you know. Good question. I will let you know. Okay.
Just
But
like
we cannot. Yes.
Just like we find the field at distance r from a point charge using Gauss. So we construct a Gaussian sphere at a distance r, and we write integral b dot ds is q in upon epsilon. So
yes,
field is variable with r, but for this Gaussian surface at all points it's constant.
Yes, correct.
Therefore, we can take the b outside the integral. And
No, wait. You are doing for what? Gaussian surface, no?
Yes.
For electrostatic.
Yes, for electric.
Right. There you can do. Yes, right.
There we take the b outside. The reason is all the points.
You are taking E outside, right?
Yes, E outside, because all points on Gaussian surface, electric field is same.
Right.
Similarly, for this Amperian loop, although the magnetic field would be different if we shift the points above and below, but for this Amperian loop, it's symmetric. So we should be able to take B outside.
I will let you know. I will think. That's a good point. I'll let you know. I'll think on what way it can be on, but parallelly, if we keep moving, that's fine. But can that be alone be taken? I don't know. We will see. I will think and let you know. Okay. Yes. That's fine. Now here, that is, if we will surely consider that the finite wire is so won't be in the formula vary as we consider it of all the wires around. Mu naught I. Okay, I will let you know. Don't worry. Is that okay? I will think and let you. Fine. Where is our dash? I will let you know. Next time, please remind me.
Yes, sir. And one last question.
Yes.
There is an infinite solenoid.
Infinite?
Solenoid.
All right.
With current I and turn density N. Find the magnetic flux passing through the center of, passing through the plane via the center of the solenoid.
Center of the solenoid. Center of the solenoid. Yes,
plane through a plane.
Cutting that.
Through the center.
Okay. Achha, this is not thin solenoid. You don't want to consider B to be what is that? Constant or what?
B would be constant inside the ideal solenoid.
Then what is the problem?
So flux is integral B dot ds.
Flux is okay. Integral B dot ds. Yes.
So inside the solenoid we know magnetic field.
Right. Then multiply by simply area. That doesn't give you?
Yes, that gives
Simply,
the flux. Now,
multiply by the area, na? Beam into area.
okay, sir. Now I want the flux passing through the plane at the end of the infinite solenoid.
Acha, at the end, but not then infinite. It is finite. Then you are saying.
It's infinite at the infinite end. We say no, the field would be mu naught Ni by 2. So at that region, I want to find the flux.
Achha, okay, you want to get at the end. Quite a long solenoid we can take. Correct, na? Long solenoid.
Yes.
Right? Then it can be. So ultimately, it is boils down to getting the field at the end. Field at the end, right?
We have the field at the end, and multiplying by the area, we get the flux at the end.
Right. So that means we have to get field at the end ultimately.
We know the field. No, sir. We know the field mu naught Ni by 2.
Achha, mu naught Ni by 2. Half of the one which is at the center, right? Like
yes.
That. Okay, so two big fellows you can take midways half. Right. By you can get mu naught Ni by 2. So then again you can multiply by the area. Then what is the problem here?
So I get the final flux at the end. Where did the remaining half flux go, sir?
Remaining half flux. And okay, and then won't the at the end, if you see how the shape will be, is it will it turn or not? End effect, fringe effect won't be there. Wait, please wait. Fringe effect at the end. Wait, where is the point? Is with where is the right? Right. Okay. Now, what will be the direction of fringe at the center? What will be the direction? Sorry, field. It will be like this, na? All right. You know, 10. I feel this must be responsible. B has reduced, right? B itself is reducing. Must be that end effect. This only we call as end effect. Most because of this. This only must be the cause. Because you are finally getting B itself. Na? B itself is less, correct? Oh, your point is what has happened to remaining B? Well, it should come out, correct? Where it is going. Right. Understand. Okay. This one.
Is it a problem because we're dealing with infinity?
You need in?
Is this the problem because we're dealing with infinity?
Then Shrey is saying that finite solenoid or then for infinite. Not necessary infinite. Don't say it as infinite. So okay, finite only. Flux at the center and field here and field here are different, actually speaking. So flux will be different. It is because of fringe effect only can be reasoned out. That okay. So it comes and it goes like this. Here it is like this and it comes. So like that it will keep coming. But here at the end, if you see, it won't come out and it won't turn. It won't come like this and it won't turn. If it would have been like this, then you will get the same field. Field is not same. Is that right? So how the but perception thing. Right. Okay. See, you think like this, na? In other words, you think this is a solenoid, okay? Right. Now, say there is some flux, right? Field here, right? You bring one more solenoid, identical solenoid, place it here. Now, field will be it will go like this, but okay. Oh. Yeah, actually, end effect is the reason. End effect should be the reason. Let me confirm that. End effect should be the reason. It won't come like this and exactly make an abrupt turn or something like that. So it will keep going. So here, that angle made, is that okay? So B dot A, when you take, the field lines won't be coming perpendicular here. Whereas if you see in the middle and all, it will be section, it will be perpendicular. So here it won't be perpendicular. It will be inclined so that it starts turning. Correct. At the end, it starts turning. Is that fine? So this must be the cause. Actually, must be. Let me still confirm that. That okay? Don't
So
worry.
density of M logs along that cross section would be variable. Means change at the end.
Density
of the magnetic lines of force through that cross section
will be
non-uniform.
Yes. Or else then why flux will be field itself change? That is clear. For you, your question is what has happened to that flux? Why it has not reached here? Because field itself is good. That means for you, reason we have to reason why field is not that much. It has got reduced only. Is the logic clear? As you come near the end section, field is reducing. Correct. So that means if we get reason for that, fine. But I somehow feel that it can be end effect. Let me confirm that. Not a problem. Okay.
Then maybe the field at the axis wala point it has reduced to half, but at the peripheral points it would have some increased a bit because the magnetic lines of force have.
Then that at the end you are talking about at the end then. Because at the middle and all, this radial variation of B we are not considering. Everywhere it is uniform B. At the middle, at the center, that is center of along the length of the solenoid, midpoint of the solenoid.
So at the ends in the radial direction, magnetic field would be increasing. and it would be increased such that the integral value should come out to be same as that at the center to get the net flux.
Again, repeat.
The flux should have remained constant. So to keep the flux, the amount of flux same as that found at the center of the solenoid, the magnetic field would increase in the radial direction. At the axial point, it is mu naught Ni by 2. In the radially outward points, it would have increased a bit. So that if we integrate that quantity b dot ds, the final value of the integral we get would be same as the flux at the center.
But why b dot dl? Why are you saying b dot dl?
No, sir, b dot ds.
Acha, b into area, and you are saying that radially it is increasing.
Yes.
That means if you see this section in your thing, you say here it is b, then here it will be slightly bigger, then here still bigger, like this you are saying.
Yes, sir. Because only that can handle the value of integral to be equal to that found at the center.
Oh, you are now saying finally flux should be same. That for that you are saying.
Yes, sir.
Then when you multiply that ends field at the end, the field multiplied by the area, you are multiplying the taking entire area, no? So that means we are considering that to be same throughout. Okay, yeah, that is radial variation of B. That is what is your point. So mu naught I by 2 is at this midpoint, that axial point of that end.
Yes, sir.
Like that you are saying. So your point, it won't be like that. Then you cannot tell that as the answer. No, into hard, because you are claiming that the answer is also mu naught Ni by 2 into that area. That also you are claiming. Then why you are again saying that radially it will increase, so that you are trying to bring that remaining half the flux will be in that area only? You are telling the answer, no, and that answer is correct. No, mu naught Ni by 2 multiplied by area. That is correct, right? Or that is, you are saying that you suppose that, or is it correct only?
Answer given in the book was mu naught Ni by 2 into area.
Into area. That means why will that area is completely till the periphery, na? That area is including everything, na? Then why are you trying to increase only this? If you increase, then answer will be wrong. The thing is, your point is where then remaining flux has gone. Is that okay? So if probably this ends, let me confirm it, but I feel this, if it ends means, then here this is all fine. Axial be okay. Whereas here only it will keep going out only like this. This is all fine. End effect. Here only the field would have gone somewhere, and like the field is reducing. Fine. Magnetic field is reducing. It would have gone here. End effect, they say. Is that okay? Because of that now, flux itself is less. If field line would have only come out like this. Are you getting? In the
Turns are
sides?
present, so can it exit like that?
Yes.
Turns are present over there, wires turns. So can the field lines exit like that?
Turns are there. That is what you are saying, na?
Yes, sir.
I think because of ND effect, because of ND effect. That's why I'm telling you, I will confirm also, because of ND effect. Is that okay? So, or else you completely all the, see, do you mean that it will come like this and then only turn like this? I don't know. I like this coming out, then turning. Till this, it is uniform like this. No. If such is the case, it will be then mu naught I by mu naught I into area only. Since mu naught, and definitely this angle will be there because of the angle only, area like this and this angle B probably will be resulting, and exactly half is gone in that probably. Is that okay? That we cannot tell by by this judgment, but yes, that is what I feel. Let me confirm. Not an issue. Okay, got it.
Yes, sir.
Let us see. I got it. One is for
Thank you.
segment. Another here is a segment that wire should be long for segment actually, or else anyway. Okay, that I will confirm. And this is your flux at the end. Okay, fine. Let me confirm also. Is that okay? Fine. Let me find out the reason. Don't worry. Done. Our hero Darshan. Oh, okay. Nice. Yes. Good. Okay, then shall we end? Any other questions? Okay, yeah. Thank you. Yes, same to you people. Take care. We'll see next week. Yeah, that's fine. At the end, we will discuss next week. At the end or somewhere in the break, we will discuss. Don't worry. Yeah. Thank you. Bye then. Yeah. Madam, we will end, madam. Madam.
Hello.
Madam, we'll end, madam.
Okay, sir. Sir, you are host, so you can only end the meet.
Oh, okay. Sorry, madam. Yes. Thank you, madam. Okay. Yeah, thank you.
Okay, sir. Thank you for your valuable
Thank
time.
you. Yes, madam. Thank you, madam. I only can end it. Okay.